Using the law of sines, we need to show that in a triangle ABC, cosine of 2a over a squared minus cosine of 2b over b squared equals 1 over a squared minus 1 over b squared. So let us define the law of sines first. So if we have a triangle ABC, where angle A, angle B and angle C, the sides opposite to it are represented by the letter A, B and C respectively. Then the law of sines states that the ratio of side A to that of sine of the angle A will be equals to the ratio of side B to that of sine of the angle opposite to it, which is B, and this is also equals to the ratio of the third side to that of sine of the angle opposite to it, that is C. So this is the law of sines. Now in order to solve our problem, what we'll do, we are going to consider that let these three ratios be equals to 1 over lambda, such that we can represent sine of A as equals to lambda times A. Then sine of B will be equals to lambda times B, and sine C will be equals to lambda times C. So let us begin from the left hand side of a given expression. Now in the first term we have cosine of 2a over a squared, but we also know there is a standard formula for cosine 2 theta. So cosine 2 theta is 1 minus 2 times sine squared theta. So cosine of 2a will then become 1 minus 2 times sine squared of a whole divided by a squared, minus we have the second term which will be 1 minus 2 times sine squared b whole divided by b squared. That will be equals to 1 over a squared minus 2 over a squared times sine squared a minus 1 over b squared. So we have a negative sign here, so negative of negative will become positive. We have 2 over b squared multiplied to sine squared b, which will be equals to, we have 1 over a squared. So let's combine it with the third term. We have 1 over a squared minus 1 over b squared, minus the second term, which is 2 over a squared times sine squared a, but we can replace the value of sine with lambda a to get lambda squared times a squared, plus 2 times b squared multiplied to sine squared b, so this will become lambda squared times b squared. So here a squared and a squared get factored out, and in the fourth term b squared and b squared gets factored out, and finally we're going to get 1 over a squared minus 1 over b squared. So this is simply negative 2 lambda squared added to positive 2 lambda squared, which adds up to give us 0. So we are finally left with the result on the right hand side. So we have successfully showed that the left hand side of the expression equals the right hand side, hence proved.